All right, welcome back for lesson 2, which are two-step equations. Two-step equations can look a multitude of ways. So I'm going to go through 3 different examples that will show you different ways to solve them and how the two-step equations might look a little bit differently. All right. So with this first example, it's a pretty simple standard two-step equation. The definition of a two-step equations means that we need to do 2 inverse operations to be able to solve for that variable. So with this, of course, our variable is x. The 2 things that we have that we need to take care of to solve this equation is both this 9 and the 3. More specifically, it's an addition of 3 and a multiplication of 9. So if you see again, the addition of 3 is causing the problem of x not being isolated, as well as that multiplication of 9. So those are the 2 things that we are going to need to fix to be able to get the x isolated. So with problems like this, we are going to start with the problem of addition of 3, and to solve that, to fix that, we need to subtract 3 from both sides. Once we subtract 3 from both sides, this is canceling. We are left with 9x is equal to 30. All right. At that point, we then move into dividing by 9. We want to, again, fix this multiplication of 9 as an issue, which the inverse operation is to divide by 9. So we're at this section here where we're dividing by 9. 9 over 9 is 1, so we're left with x is equal to 9 over 30. I'm sorry, 30 over 9. We can simplify that. We can divide each of those by 3, so we get 10 over 3. Again, what we did there was we divided by 3, divided by 3 to get 10 thirds. And we can leave that problem like that. All right, next option is one that's going to end up looking the same in the long run. But as you notice, when you first look at this problem, you can see that we need to do something before we can even get moving. That thing would be the distributive property. As you remember, distributive property means this is 2 times the quantity x plus 4. So we need to multiply and distribute that 2 to that quantity. So we end up with 2x plus 8. All right, again, that was 2 times x gives us 2x. 2 times 4 gives us 8. Now we're back at what looked just like that problem that we did last. And we're at the two-step equation. 2 problems that we need to fix, 2 operations that we need to develop before we can get the x isolated. Again, those would be the addition of 8 as well as the multiplication of 2. All right, so we are going to start with that addition of 8. The inverse operation of addition of 8 is subtraction of 8. So we subtract 8 on the right-hand side. We subtract 8 on the left-hand side. We're left with negative 5 is equal to 2x. At this time, we just have the multiplication of 2 that is left. So to take care of that, we need to divide both sides by 2, leaving us with x is equal to negative 5 halves. Okay, negative 5 halves. All right. Very good. The third example that I want to look at is this one. Now notice again, we do have 2 issues why that x is not isolated. We have the division of 3, as well as, if you don't look at this, you can see that that's just a positive 5, which we would consider an addition of 5. Okay? With this one, that division of 3 has locked in the 5 and the x, so the only way to deal with this to start is to multiply both sides by 3. Again, that would be that inverse operation of the division of 3. So multiplying both sides by 3, on the left-hand side, of course, we get 6. On the right-hand side, the 3's cancel. That unlocks that 5 plus x that's in the numerator. And then we're left with a very simple one-step equation. Again, we have that addition of 5 that we need to take care of. So to take care of that, we subtract by 5. X is equal to 1. All right, so those are 3 examples of how to work on these. The assignment is posted with this video, so go ahead and work on that assignment. If you have any questions, please, again, don't hesitate to email me.